Hi everybody, my name is Bhavashya and in this lecture we'll see how ABR works in this particular topology. So in the previous one we saw the similar example, but this is extended topology. Here I have added R4 in the area 0 to R1 which was single area router, and similarly here I've added R5 with R3 which was single area router before, and this whole right side of the ABR is area 1 and the left side of the ABR is area 0. Now as you know that ABR stands for area border router, which is responsible for one network, which is responsible to send one area network to another network area with the help of network summary LSA. So we will see that how many network summary LSA is being generated, who will generate it, for whom, for which area, and so on. Right. So first let's go and configure, as I've already configured it to save the time. So the important point is that the question that will arise. Okay, so let me give you a brief of what we have configured. As you can see, I've configured in R1, I've configured this area, right? But the special part is that I've in the network I've given point to point. So in this area 0, in between R1 and R4, it is point to point. That means no DR or BDR will get selected here. But when it comes to R1 and R2, here R2 is being selected as designated router due to higher router ID, and R1 is selected as BDR. Similarly, if you look at area 1, let me pull R3. Okay. Here I have in between R3 and R5 I have given point to point, point to point. So no BDR is getting selected in between R3 and R5. But here when it was getting elected, so R3 got elected as designated router and R2 as backup designated router. Right. Yes. So now the question is, how many router LSA will R1 generate? Or to extend the question, how many router LSA will get generated for area 0? As the validity of or the scope of the LSA is always within the area only, right? So the question will be same. So the answer is 3 router LSA. The one it will get generated for R4, R1 and R2. The area, the router LSA that it will generate for area 0. Right. Similarly, if we talk about area 1, so it will generate 3 router LSA. First one is for R5, the second for R3 and the third one for what R2 will generate for specific area 1 network. Area 1, area 1, right? Now, the important question is about network summary LSA, right? So, as if you look at area 0 as the LSA's range is always within the network, and to get the information about other network, we have to take the help from ABR, as ABR generates network summary LSA from one network to other network, right? So as area 0 do not have any information about area 1, so R2 will send network summary LSA having network 23.0.0.0 and having network 35.0.0.0, which is all, both of these were under area 1 to area 0. For that, R2 will generate network summary LSA for area 0 having network 23.0.0.0 and network 35.0.0.0. And if I want to validate this information, I'll go to R4 and I'll say show IP OSPF database. So as you can see the database here, as you can see the network summary LSA. So this is what it has generated for area 0 having information about 23 and 35. Similarly, if I'll go and check for our area 1, that I'll go to R5 and then I'll check. So here network summary LSA that it has generated for area 1 is this 12 network and then 14 network, right? Yeah, but if you look at both of these LSTBs, the one thing that is common in between them is the APR is same. So if I'm, let's suppose, not looking at the topology and if I'm only looking at the LSTB, so this is how I can validate. As you can see, the router ID is same, the one who has generated the network summary LSA 2.2.2, which is our R2. If you look at R4, it is same, right? 2.2.2. So yeah, this is what they have common in between. Now, as you know, that the most important part in OSPF is LSA. So as LSA carries the information about the networks, those LSA get stored in LSTB, right? And if we change LSTB, if you make a change in LSTB, so algorithm called SPF, shortest path first, get enabled for it, and then for different networks it get enabled, and then for that different networks the best possible path or routes get generated, right? So to validate this information, we'll go and type show IP route. So let's do for R4. So when I do that show IP route, this is what I'm getting. So it says I've learned about 23.0.0.0 network. How? With the help of OSPF. Not only a normal OSPF, but IA. Now what does this mean? So IA stands for OSPF inter area. That means that it was outside my area, not from same area. So basically it has learned from network summary LSA, right? Yes, inter area. Similarly, if you look at R5, so this is what it says. 12.0.0.0 learn from inter area, OSPF inter area, right? Now the interesting part is, as we are looking for R5, let's suppose it learned about this network 12.0.0.0. So it is saying that the next hop is 35.0.0.3. So the next hop for R5 is this particular, R3 is this fast Ethernet 1/0. And if we look at R3, so the next hop for that will be this particular 23.0.0.2. Let me validate. As you can see, the next hop is 23.0.0.2, 12. And similarly for R4, the next hop will be 14.0.0.1. So 4, as you can see, right? And if you look at R1, so the next hop will be 12.0.0.2. Here, as you can see, right? So now as we have looked for area 0 and area 1, let me extend the topology and let me pull out one more router here, R6, and we'll make it area 2, let's suppose. So let me pause it here. Okay, so we have area 2 here as you extended the topology with R6 with this network 26.0.0.0. Now if I ask how many network summary LSA will R6 have, so what will be the answer? So the answer will be 4 for network 14.0.0.0, for network 12.0.0.0, for network 23.0.0.0, and for network 35.0.0.0. And if I ask about how many network summary LSA will R3 have, then what will be the answer? The answer is 3. Network 26.0.0.0, 12.0.0.0, and 14.0.0. Similarly, if I ask about R1, so the answer will be same 3. 26 network, 23 network, and 35 network. Right? Yeah. So this is how ABR acts when it is being attached to different areas, right? This is how it generates network summary LSA. So yeah, this was it for this lecture. I hope you enjoyed. See you in the next one.